Derivative as a rate of change. Motion along a line. Displacement, velocity, speed, acceleration, and jerk. That was the thing that we go over today. Suppose s equal f of t is the position function of an object that moves along a coordinate. The displacement of the object over the time interval from t to delta t is given by delta s equal f of t plus delta t minus f of t. So they're just saying the distance from where to start. So say you have here's the line, and you have an object moving along the line, and it move up and move backward and move up and maybe moving backward, whatever this is, right? Then the displacement t and t plus delta t, this is where the object end up. Then s of t, then delta s is equal to f of t plus delta t minus f of t. Okay, and we'll talk more about this in a little bit. The average velocity equal to the displacement divided by the time it takes to travel. So this formula is basically based on the formula distance equal to rate times time, or distance equal to velocity times time. So then velocity equal distance divided by time, or it's the displacement divided by time travel. Velocity, the instantaneous velocity, is the derivative of the position function with respect to time. If a body position at time t is s equal f of t, then the body velocity at time t is equal to the first derivative of the position function, and we can calculate that using the limit definition. Okay. So if v is greater than 0, would mean the object is traveling in the positive direction. If v is negative 0, means the object is traveling in negative direction. So let's see here, this is a straight line, and the object moving in this direction. So this portion here, v of t, is greater than 0. So then at this point, the object move around, turn around, make a U-turn, and moving backward. So in this portion, v of t is less than 0. The speed is the absolute value of the velocity. The speed is always positive. Okay. The acceleration is the derivative of the velocity with respect to time t. If a body position at time t is s equal to f of t, then the body acceleration a of t is the first derivative of the velocity function, or it is also called the second derivative of the position function. The jerk is the derivative of the acceleration with respect to time. Let's take a look at our first example. Given s equal f of t equal to t squared minus 3t minus 2, for t is between the interval from 0 to 3, find the displacement and average velocity for the given time interval. The displacement delta s is equal to f of t plus delta t minus f of t. Here we look at the interval from 0 to 3. So t is equal to 0. T plus delta t is equal to 3. So then f of 3 minus f of 0 equal to 0. So then after 3 seconds of traveling, the object ends up where it started. the average velocity is equal to delta S divided by delta T. Delta S equals 0, delta T equals 3. So the average velocity here is 0 meter per second. So it looked like the object didn't move at all, which is it really the case? What happened here? In the next case, we want to find the speed and acceleration at the end point of the interval. So the speed, v of t, is equal to f prime of t. V of t equal f prime of t. So that equal to 2t minus 3. We want to find the velocity at the end point. So v of 0 is equal to 2 times 0 minus 3. So the object moving backward at time 0. At v equal 3, 2 times 3 minus 3 equal 3 meter per second. So here the object moving forward. The acceleration, a of t, is equal to v prime of t, that equal to. So it accelerates 2 meter per second square. So the question asks, well, it looked like the object here moving backward. It's starting out move backward. And it moving forward in this case. Or moving to the negative direction. And move in the positive direction. So the question is, when did the object change the direction that it's traveled? We then have to start with the velocity function. V of t equal 2t minus 3. And we want to know when does it move in positive. When velocity greater than 0. So here t is greater than 3 over 2. This meant that as it's starting out, the object moving in the positive direction at the time interval of 3 over 2 to 3 and move in the negative direction from 0 to 3 over 2. Okay. Let's take a look at the next problem. At the time t greater than or equal 0, the velocity of an object moving along the horizontal line is v of t equal t squared minus 4t plus 3. Find the acceleration at each time the velocity is 0. Okay. So first we need to find the velocity function. Velocity that is given to us, that is t squared minus 4t plus 3, and we want to evaluate this. We want to find the value of t would make that equal to 0. Okay, so this is t minus 3 times t minus 1 equals 0. So t equals 3 and t equals 1. And we want to evaluate the acceleration at each time that the velocity equal to 0. So a of t is equal to 2t minus 4. So a of 3 is equal to 2 times 3 minus 4. That equals 2 meter per second square. A of 1 is equal to 2 times 1 minus 4. That is negative 2 meter per second square. In the next question, we are asked to find when is the velocity of object moving backward or forward. So recall v of t greater than 0, the object moving forward. When v of t is less than 0, the object moving backward. Now, we have the value in which v of t equal to 0. We can test it out. What is the value of t in certain interval? So here, the time. And the time for t is greater than 0. So start out at 0. The next point is 1, 3, to infinity. Which means we are really looking at the interval 0 to 1, 1 to 3, and 3 to infinity to see in which interval does v of t become positive. To do that, I can pick a test value. V of t is factored into 2 factors. I will put it down. And the conclusion is our v of t. Okay. So in the first interval from 0 to 1, let's pick the value 0.5, 2, and 4. When t equals 0.5, t minus 3 is a positive value. This is a negative value. This negative, positive, positive, positive. Which means v of t is negative in the interval from 0 to 1, negative in the interval from 1 to 3, and positive from the interval from 3 to infinity. This means v of t here is moving backward. In the interval of 0, 1, union 1 to 3. Moving forward in the interval of 3 to infinity. When is the velocity increasing and decreasing? If you remember the first derivative test, if a of t, if the first derivative is greater than 0, then the function increasing, and if the first derivative less than 0, then the function decreasing. So this is the case. A of t is greater than 0, which means v of t will be increasing. A of t less than 0, then v of t decreasing. So start with our function a of t. A of t equal 2t minus 4. If this is greater than 0, then t is greater than 2, which means that v of t is increasing in the interval 2 to infinity. V of t is decreasing in the interval 0 to 2. Take a look at the next example. Let's say you're bored, so you entertain yourself. You shoot a paperclip 64 feet straight up in the air with a rubber band. in t seconds after firing. The paperclip is S equal 64t minus 16t square feet above your head. How long does it take for the paperclip to reach its maximum height? And with what velocity does it leave your hand? You noted that the position function is a quadratic function, and that is the graph of this function is open downward, which means the paperclip reach maximum height at vertex. Okay, so to find the vertex, t equal to negative b over 2a, and that is negative 64 over 2 times negative 16, that makes 2. So the paperclip with maximum height at t equal to. With what velocity does it leave your hand? This man is asking for the instantaneous velocity when t equals 0. When t equal to 0. It's asking for v of 0. But at the exact moment, what is the velocity? So v of t is equal to s prime of t, that is 64t minus 16t squared, and that, the derivative of this is 64 minus 32t. Okay, so at t equal to 0, v of t is equal to 64 feet per second. We also use derivative in economics. Economists have specialized vocabulary for rate of change and derivative. They call them marginal. If C of x is the cost of producing x unit, then the marginal cost of production is C prime of x is the rate of change of cost with respect to the level of production. You can think of C prime of x as the cost of producing one additional unit. Suppose that it costs C of x equal to x squared minus 6x squared plus $15 to produce x radiator when A to 30 radiator are produced, and that the revenue function is given as x to the third minus 3x squared plus 12x. Give the dollar revenue for selling x radiator, and your shop is currently produced 10 radiator a day. How much will it cost to produce one more radiator per day? So first, let's find the derivative of the cost function. C prime of x is equal to 3x squared minus 6x plus 15. So the cost to produce one more radiator per day, right now you produce 10 radiator. So C prime of 10 is the cost to produce one more. So that be 3 times 10 to the second minus 6 times 10 plus 15. This is $195 per radiator. In part B, what is your estimate increase in revenue and profit for selling 11 radiator a day? So the profit is equal to the revenue minus the cost. Okay. Now, we will solve this based on the cost of producing one more radiator per day, because right now you only produce 10. Okay. And to sell in 11 radiator would mean one more than already producing. Okay. This means we want to find P prime of 10 that equal to R prime of 10 minus C prime of 10, and that is 10 square minus 3 times 10 plus 12 minus 10 square minus 6 times 10 plus 15, and that is 57 per radiator. So if you produce one more radiator than what you already produced then, and sell that for profit, you make another $57.